This video is going to continue our discussion on polynomials, and we're going to talk more about operations with polynomials. Remember, when we say operations, we mean addition, subtraction, and multiplication when we refer to polynomials. Down later on the road, we will discuss why we're not necessarily talking about division right now, because there's a concept that we'll learn. It's called the closure property, and they are not closed under division. So before we can start this, let's review what is a polynomial. So a polynomial is an algebraic expression with many terms. Remember, poly means many, and nomial means part. And in our case, those parts are called terms. You have a monomial. You have a polynomial. Remember, more than three, we just call poly. You have a binomial, 2 terms, and a trinomial, 3 terms. We just discussed this yesterday. Now, the standard form, this is important to understand, because as we do these operations, our final answer should always be submitted in standard form. Standard form is when we order the degrees from largest down to smallest and alphabetical order. So if we have 2 terms that have the same degree, we put it in alphabetical order at that point. So when we look at this one, if you look, you have x plus x squared plus 4, where x has a degree of 1, x squared has a degree of 2, and 4, since there is no variable part, it has a degree of 0. So when we put this in standard form, it's x squared plus x plus 4. That there is our answer in standard form. Let's go look at it when we start putting in more than one variable. The concept still applies, that negative and addition sign separate our terms. So here we have a term with a degree of 1. Here, since there is no variable, its degree is 0. Here, the degree is 3. And here we have something a little different. We have an x, and its exponent is 1. Remember, when it's not written, it's a 1. And then the y, which has a 3. So we have to now, because they're in the same term, add that together to get a degree of 4. So our first priority is ordering by degree. So here we're going to have 3xy cubed because its degree was 4. Then we have 2x cubed plus 5y, and I know it's a plus because that 5y is a positive value. And finally, minus 4. That right there is my polynomial in standard form. So that's a review of the concepts we covered yesterday. But what about this expression? So it's an expression, there's no equal sign. If I wanted to write something equivalent, meaning equals, it means the same thing, by combining like terms, that's how I'm going to do this. What do I need to do first? Because there's something I have to do before I can do that. Does anyone know? I'm hoping you said to take these 2 and distribute. When you see parentheses and a number right next to it, it means we're going to distribute. So I'm going to distribute my 3r to the 4r to get 12r squared. 3r to the 5s and get negative 15rs. Then my 2r gets distributed and I get negative 12r squared. And then I distribute it again to get negative 18rs. So I've done that now. So we're still working with this original problem. And I wanted an equivalent expression in standard form. So we took our first step and we got this. Well, how do I do that? How do I now take this? It's a polynomial. It is now a polynomial because there are 4 terms. How do I write it in standard form? That's right. I combine like terms. So my like terms are 12r squared and negative 12r squared. Well, negative 12r squared and 12r squared, those two will end up canceling out. A positive and a negative, those are gone. Then I have negative 15rs and negative 18rs. When I combine those, I now get negative 33rs. I have now written an equivalent expression. Okay, so let's now go through and add our polynomials. If you take a look at example A, I have two binomials that I'm adding together. I had a student once say, I'm adding them. Don't I just write them as they are and combine like terms? And I said, that's exactly what you do. So what you're going to take exactly what's in your first polynomial and exactly what's in your second. So I have 5x and 8x to give me 13x. Negative 3y and 12y to give me 9y. That right there, that's it simplified. I can't do anything else. I can't combine the 13 and the 9 because one's an x and one's a y. I have now added my two polynomials. Now, when it comes to subtraction, there is a step you have to do first. And it's super, 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 super important you remember that. Go back to what we did last week with the distributive property, okay? Right there in front of that second polynomial is a number 1. This one is a negative 1. On A, there was a 1 there as well. It just happened to be positive, so we didn't have to do anything. So now what I'm going to do is I'm going to write my first polynomial exactly like it is, nothing different. I'm then going to distribute my negative 1. I'm now going to get negative 1 and 6/10 A. Then I distribute my negative 1 again and get a positive 3 and 2/10 B. I am now at this stage where there's no more parentheses. I can combine my like terms like we've done on the past two examples. So I'm going to start, I have 7/10 A and negative 1 and 6/10 A. When I combine that, I get negative 9/10 A. I then have 4/10 B and 3 and 2/10 B. When I combine those like terms, I get 3 and 6/10 B. I'm emphasizing how to properly say these decimals because we need to start remembering our place values. We need to remember where we round to when we're told to round to the nearest tenth or round to the nearest hundredth, okay? So at this point, we've done it. We've simplified our two expressions, okay? So let's take a look at something that we might see in the real world. We have two different clothing factories. They have come up with a model for their amount of shirts produced. They're telling us S is the number of shirts produced at the factory. What these represent is their profits. So factory A has the polynomial and then factory B. They're wanting to determine the difference between the two plants. Okay, so difference. Well, we know we're going to have to take factory A and factory B, just as it is, okay? But difference tells us we are going to subtract. So when you subtract, we need to put parentheses around factory B and write factory A again, just as it is, okay? Then I'm going to distribute that negative 1. So negative 1 times a negative is now a positive. Then the negative 1 times a positive now makes that a negative. And finally, I end up now with another positive. So you should be realizing now, I've done this, there's no parentheses, I can combine like terms. So I have negative 6/100 and 4/100 to give me negative 2/100 S squared. Then I have 43S minus 32S to give me 11S. Then finally, I have negative 1600 plus 1500 to give me negative 100. That expression right there tells me the difference between the two factories' profits. Okay. Now these models, these expressions, they will help businesses figure things out. For example, this now says, write the total in the profits of the two plants. So total would tell this corporation how much money they're benefiting from both. So what that tells us is we take factory A and factory B, but this time total tells me to add. I still want to put my parentheses because I want you to remember something. I'm adding everything in A to everything in B. So what you need to realize is exactly as A is written. Then I'm going to write exactly B. Look at what B was this time. It's 400ths s squared. So rather than write plus that, I'm writing a negative because my term was negative. I'm going to write the 32s as a positive because when it was written for factory B, it was a positive. And then I write a negative. Now I combine my like terms the same way. So these two now, it's going to combine differently to give me negative 10s squared. Okay, 10 hundredths, I'm sorry. Then I now have 43, but this time it's plus 32. So I really get 75. And then when I combine these two, there's a little difference now. Last time my 1500 was a positive. Now it's a negative. So now these two numbers actually get added because they're the same signs. So therefore it's negative 3100. So what we have to realize here is we're still doing combining like terms the same way, but our positives and our negatives being distributed change. So don't assume because it's the same expressions, you're going to get the same answer. So let's take a look here. This one's a little harder, and I'm going to challenge you to pause it. Pause this video now and try these two on this problem, not two, I'm sorry, this one on your own. I'll read it to you before you pause it, but I suggest trying. Stephen is 5 years older than Lilith. Colmaine is twice Stephen's age. Write a polynomial that represents the sum of their ages in standard form. Okay, if you paused it, that's great. Let's see how you did. First, I'm going to create a variable. The reason why I'm saying let A equal Lilith's age is because in that first expression, they said Stephen is 5 years older than Lilith. So I had to first find Lilith's to then find Stephen's. And then the second sentence based Colmaine's age off Stephen's. So the bottom line is we need to find Lilith's first, and then we can find everybody else's. So here's how I set mine up. We have Stephen. He was 5 years older than Lilith. And remember I said Lilith was A. Well, Lilith, we said, was A. Now, Colmaine was twice Stephen's age. But remember, Stephen wasn't just one thing. He was a binomial. So I needed 2 times that binomial. It then said the sum. If you don't know it, we need to commit it to our memory. Sum means to add. So I'm going to add A plus 5 plus A plus 2 times A plus 5. Now there's a lot here. And before I can do anything, I need to distribute this 2. So I get 2A plus 10. Everything else gets rewritten. Now parentheses are gone. I don't have to do anything but, you got it, combine like terms. So I have 1A, another 1A, and a 2A. That's going to give me 4A. Then I have a 5 and a 10, and that gives me 15. That right there, that's the answer to this problem. That is a polynomial, and it is in standard form because the constant's at the end. So you have done what the problem has asked you to do. I know there's a lot of examples in this one, and we're going to practice and practice and practice. But I wanted to touch on this only because this problem kind of takes into what we did last week with the distributive property when we do our either box method or our distributive property method of binomials and our adding of polynomials. So here they give you an example of what he's building. He's building a room that's adjacent, means next to his living room. Both rooms will have the same width, meaning both rooms are going to be x plus 4. But their lengths are different. So it says write an expression for the total area of both rooms. Your brain needs to realize, okay, these are rectangles. I'm finding the area. That should tell you to do length times width. So first, I need to find the area of the living room before I can find the total area. So my length is 2x plus 6, and my width is x plus 4. It's a rectangle. You know I'm multiplying. So I'm going to do this multiplication by using the distributive property. Later, we're going to call it FOIL. So we're going to FOIL. Here's why it's FOIL. I first multiply the first ones. So 2x times x, 2x squared. I multiply the outer ones. 2x plus times 4 is 8x. Then I multiply my inner ones to get 6x, and then I multiply the last ones to get 24. The only like terms are 8x and 6x, so I get 2x squared plus 14x plus 24. That right there is the area of the living room. Everyone with me? Remember, you can pause at any point to write this down. Okay. I also have to find the area of the game room. Remember, the widths were the same. So now I'm going to have x minus 4 times x plus 4. The x plus 4 didn't change. So can you pause now and try and FOIL this or distributive property on your own and see what you get? Okay, so here's how we do it. Let's see if you were right. You have x times x, which is x squared. X times a positive 4, positive 4x. X times a negative 4, negative 4x. The negative 4 times 4 is negative 16. Did you get that line? Okay, good. Our only like terms are right here in the middle, our x values. Yes, there's an x squared, but that has a square on it, so it's not a like term. So when I combine these, I'm left with x squared. Those cancel out. A positive and a negative of the same thing, they're gone. And then negative 16. So that right there is the area of my game room. So remember, we had the area of our living room. Now I have the area of my game room. So I technically have not answered this question, and that's kind of the challenging part here. You've done a lot of work, but you still haven't answered it. Because it says total area. Remember, living room and game room have to combine to a total area. What does total mean? Right? Total means I'm going to add. I'm going to take my living room and my game room, and I'm going to add them. Now, some of you may be sitting here saying, that's not how we've been adding. You're right. This is another method. This is a method that actually Mrs. Nell prefers. She lines up the like terms, and she does it vertically. So this is one of the few places we disagree. But what you do is we combine our like terms. So I have 2x squared and 1x squared to give me 3x squared. I then have 14x, and there's nothing underneath. So some of you might want to write plus 0 as a placeholder. That might help you. But what it ends up being is just 14x. Then I'm going to go to my last constants, 24 and negative 16, combined to a positive 8. You have now added your two rooms. So that right there is your total area. That is the answer you would type in on an assessment or find in the multiple choice options, whatever the question might be. Okay? So some problems involve multiplying and adding, and there's a lot of steps that are coming about now. So there was a lot discussed here. Some of you might understand it because some of this is not new, especially the distributive property and combining like terms. If you don't get it, leave a comment so that way Mrs. Nell and I know what to target tomorrow in class to help you. But no matter what, take that time to reflect on your summary in your notes.